Welcome to BSc Statistics students. So in this lesson I explain Johnson's algorithm to obtain optimum sequence for n jobs and 2 missions, which means it is a procedure of n jobs and 2 missions in sequencing problem, right? And if you directly come to the step 1, this is an algorithm, and step 1 if we discuss. So here we have to consider the step 1, the processing times, the processing time of Tij, that is I is equal to 1 to and so on n, which represents jobs, and j is equal to 1 to 1 and 2, two missions A and B, for example, you consider. Then the processing times are T11, T21 of mission A of n jobs, or T11, T21, T31 and so on Tn1. First letter indicates I and second letter indicates the mission, number of mission. For example, here the mission is 1, first mission. And similarly, come to the processing times of mission B, which are T12 of n jobs. Mission B, processing times of mission B of n jobs, or let it be T12, T22, T32 and so on Tn2. So second letter 2 indicates mission, J is equal to 2, and first letter indicates n jobs, right? Now you have to examine, and then after observing the processing times, now we have to examine Ti1s and Ti2s, and for I is equal to 1 to and so on n, and you have to find out minimum of Ti1 and Ti2. That is, among all the processing times, you have to calculate minimum processing time. Okay, let it be it occurs at for some I is equal to k. Okay, this value occurs for some I is equal to k. Then we have to go for next step, step 2. If the minimum processing time is for mission A, that is whatever the minimum processing time for some I is equal to k among all minimum of Ti1 and Ti2, I is equal to 1 to n, and j is equal to 1 comma 2. If the minimum processing time is for mission A, then process kth job at first of the sequence, that is from the beginning, at the beginning, right? And if it is for mission B, then process kth job at the last of the sequence, that is the end of the sequence, from the end of the sequence. This is what the step 2. And coming to the step 3. The step 3 is if there is a tie in the selection of minimum processing time, then we may arise the following 3 cases. For some I is equal to k of mission A, and for some I is equal to r of mission B. We are considering 2 particular values, I is equal to k and I is equal to r, which are having tie. That is, in the case 1, if the minimum processing times are same, one from each mission, that is one from the mission A and another one from the mission B, that is first mission, second mission. Then process kth job, that is of mission A, kth job from first of the sequence, and rth job of the mission B from the last of the sequence, right? So this is what the case 1. One processing time, one minimum processing time is of mission A, and second one another minimum processing time, the same processing time, because tie. One more minimum processing time it is for mission B. Then you have to place corresponding to mission A from the first of the sequence, corresponding to mission B from the last of the sequence. That is case 1. Coming to the case 2. What is case 2? If the minimum processing times are same in mission A only, whatever 2 processing times which are same for mission A only, then select the job with larger processing time in mission B, which means in this particular case we have to observe what are the processing times of mission B, and in which you have to consider the larger processing time of in mission B, and process the corresponding to the a particular job which at the from the first of the job sequence, because the minimum processing times are corresponding to mission A, and the second, and then you have to process the next job next to it. That means after the one particular job you have to process the next processing time. job having the processing time, minimum processing time, right? That is the case where in the, which means if the minimum processing times are same in mission A, then you have to observe the processing times of B corresponding to the jobs. For which particular jobs tie occurs of mission A, then you have to observe the processing times of mission B. Which is larger, you have to place it at first of the sequence, and next one you have to place in the next of this sequence, that is after this particular job. That is case 2. Case 3, that is here, if the minimum processing times are same in mission B only, that is for of corresponding to mission B, the two particular minimum processing times are corresponding to mission B, then select the job with larger processing time in mission A. Then you have to select, you have to see the what are the processing times of mission A of same particular jobs. Then and we have to process which is the largest, that which is having the largest processing time. Then we have to consider the corresponding job. It is going to be placed from last of the sequence, in the job sequence, and then process the other job next to it. That is, before that you have to place the next particular job corresponding to the after processing the one particular job from the last, and then you have to place this next job, right? These are the three cases, and this is the procedure to how to handle the number of jobs which are having minimum processing times are having tie. Okay, or 2-3 jobs having tie, then you have to do this is the procedure to put in the optimum sequence, optimum job sequence, right? And then step 4, cross off the jobs which are already assigned. Whichever the job is assigned, then you have to cross that particular job. If all the jobs have been assigned, then go to the next step. If all the jobs have been assigned, then you have to go to the next step. Otherwise, repeat steps 1 to 3 until all the jobs put in a sequence. Until all jobs are put in a sequence, you have to do this particular procedure. And then you have to move to calculate the times, right? You see the times here. And step 5, calculate the time at which each job in the sequence will be processed on mission A by using the formula. What is the formula? Consider the time for start of first job on mission A is 0. I'm sorry. Consider the time of the start of first particular job on mission A is equivalent to 0. That is the time in for the first mission. What you have to calculate is, you have to calculate time in and time out of mission A, and time in means when a particular job is going to be started on mission A, and when it leaves on mission A. That is, leaves means when the job is finished. What is the time of a particular job is finished on mission A, which are called time in and time out. And similarly for mission B, time in and time out. And these are the times which are going to be calculated. We consider when time starts, ith job starts on mission A, ith job finish on mission A, like that. The processing times are going to be going to be calculated, right? The first starting of a particular starting time of the first job of mission A is going to consider as 0. So initial time period. Time at which ith job in the sequence finishes on mission A, it is going to be calculated by just simply adding the processing time. The time when I minus 1th job in the sequence finishes on mission A plus the processing time of ith job on mission A. When the previous job was finished on mission A plus the processing time of ith job in the sequence, it is going to be considered the processing on mission A. If you add these two, you will get when ith job in the sequence finishes on mission A, right? That is the formula of timeout, that is finishing time of a particular job on mission A. Which are the processing, which are the times, time in and time out for mission A. Now come to the next step, which which discuss about the processing time, that is time in and time outs of jobs on mission B. Now calculate the times at which each job in the sequence will start and finish on mission B by using the following formula. The first formula is going to be considered the time when the first job in the sequence starts on mission B. It is nothing but, it is going to be calculated, the first job starts on mission B is nothing but time when the first job in the sequence finishes on mission A. The next one, B. Time of ith job in the sequence finishes on mission B. It is nothing but the time when ith job in the sequence starts on mission B plus the processing time of ith job on mission B. Right, clear? So what you have to consider, the time of ith job in the sequence finishes on mission B. It is nothing but the time when ith job in the sequence starts on mission B plus the processing time of ith job on mission B. This is the second formula. That third one, the time at which I plus 1th job in the sequence finishes on mission B. It is nothing but maximum of time when I plus 1th job in the sequence finishes on mission A and time when ith job in the sequence finishes on mission B. It is not finishes, it starts. This is the formula for time when I plus 1th job in the sequence starts on mission B. It is nothing but maximum. The maximum formula we consider for a particular job starts on mission B. Okay, right? So the maximum of time when I plus 1th job in the sequence finishes on mission A, when the previous job, that is I plus 1th job, the next job, for example, I is the current job, I plus 1th is the next job. When the next job is finishes on mission A and time when ith job, that which means current job, ith job, that is if you consider I plus 1th is the next job, ith job is the previous job. Ith job in the sequence finishes on mission B. This is nothing but we have to consider maximum time. For example, I will give you an example. For example, on first job is finished on mission B, that is ith job. First job means, for example, I is equal to 1 you consider. It is finishes on mission B for 10 hours. But next job, I plus 1th job, which means second job, finishes on mission A for 15 hours. What is the time period you have to consider, which is the starting time of mission B for I plus 1th job, that is the second job? That you have to consider as 15, not 10. We have to consider maximum. For that particular time period, mission B has to wait. For example, the previous job was finished for 10 hours, but later and next job was finished on mission A for 15 hours. Then mission B has to wait for 5 more hours to start the next job, that is second job. So that is the formula. It is the starting time period, right? Time at which I plus 1th job in the sequence starts on mission B is equal to maximum of time when I plus 1th job in the sequence finishes on mission A and time when ith job in the sequence finishes on mission B. This is the formula. These are the formula for mission B, the time calculations in mission B. Time when it starts and finish, right? And coming to the step 7. Step 7 is a calculation of ideal time. Step 7 is calculation of ideal time. Ideal time for mission A and mission B are going to be calculated by using the formula. First one, ideal time for mission A. Time when it is calculated by time when the last job in the sequence finishes on mission B minus time when the last job in the sequence finishes on mission A. That is mission B total time minus mission A total time, which gives the ideal time for mission A. It is very simple. Leave it. And then ideal time for mission B, right? The ideal time for mission B is nothing but time at which the first job in the sequence finishes on mission A plus, that is for example, on first job is on mission A was finished for 8 hours. It was finished for 8 hours. Then mission B has to wait for 8 hours. That is the first ideal time for mission B. Plus summation I is equal to 2 to n, time when ith job in the sequence starts on mission B, time when ith job in the sequence starts on mission B minus time when I minus 1th job in the sequence finishes on mission B, which means ith job, for example, this is the third job in the sequence starts on mission B minus time when second job in the sequence finishes on mission B. If you calculate the difference between the next job starts on mission B minus the previous job finishes on mission B, it is nothing but the ideal time for 2 to n. That is for I is equal to 2 to n. For I is equal to 1, this is the procedure. This is the formula for ideal time. For I is equal to 2 to n, this is the formula. Right? And so that you will get the ideal time for mission B. So these are ideal times for mission A and mission B. Then come to the step 8. Step 8 is a calculation of the total elapsed time, for which what we have to calculate is simply if you go and refer on which particular time the mission B finishes all jobs. That is the last job when mission B finishes, that is finishing time. That is nothing but total elapsed time. Okay, now we have a formula. Calculate the total elapsed time to process all jobs through 2 missions. That is time when nth job in the sequence finishes on mission B. That's it. What exactly I have expressed that? This is only this particular sentence only. By using the following formula, total elapsed time T is equal to, it is summation I is equal to 1 to n Ti2 plus 2, which refers second mission, plus summation I is equal to 1 to n Xi2 is also refers the second mission. So Ti2 is processing time of ith job on mission B. Xi2 is the ideal time of mission B after completing I minus 1th job and before starting the process of ith job. Alright, this is an ideal time of mission B, right? So this is what the how to calculate total elapsed time, in which you have to calculate in the sequencing problem, you have to calculate total elapsed time, first of all optimum sequence, and then total elapsed time, ideal times. These are ideal time for mission A, mission B. How many number of missions? Here 2 missions, mission A and mission B. So this is what the procedure of Johnson's algorithm, or procedure of obtaining optimum sequence of n jobs and 2 missions. Thank you very much.